Good afternoon, everyone. I'm Li Haopeng, an Apache Doris PMC member and a senior engineer at VerityB. Today, I'm thrilled to take you on an in-depth dive into performance optimization for Apache Doris on ARM architecture, with a specific focus on how Apache Doris performs on AWS Graviton 4. Let's get started. First, let's talk about the core demos in the field of data analysis and why combination of Apache Doris and ARM architecture is a game changer. In today's message of data analysis scenario, enterprises are placing more and more emphasis on high cost effectiveness, and it becomes a key priority for industry to get the most value out of every investment in data infrastructure. Now, let's look at the ARM architecture. It stands out with its high energy efficiency and cost benefits. These advantages are making ARM rising rapidly in data centers, and it's become an ideal choice for enterprise to cut costs while boosting efficiency. And Apache Doris is an optimal choice for faster, high quality, and most effective methods of data analysis. Here are three key reasons. First, it's a high-performance real-time analysis database based on the MPP architecture. This architecture enables it to support ultra-fast processing of methods of real-time data. Second, its application scope is very wide. It's used in diverse scenarios such as a report analysis, ad hoc query, and a lakehouse query. When we combine the Apache Doris' excellent data analysis and proceeding capability with the high energy efficiency and cost advantage of ARM architecture, we get a powerful solution that meeting enterprise core needs. Next, let's focus on AWS Graviton 4. What does Graviton 4 bring us? What new feature it brings to the table? There are four key aspects. First, the number of core threads has increased by 50% compared to Graviton 3. More core thread means it can support greater parallel computation, which is critical for handling large-scale data processing tasks effectively. Second, the main bandwidth has been enhanced. They increased by 65% compared to Graviton 3. In high throughput data processing scenarios, memory bandwidth is essential to ensure the data flows smoothly. This improves the perfect means flat time. Third, the Graviton 4 adopts advanced process technology. The advanced technology helps it achieve industry-leading energy efficiency. For enterprise, a higher energy efficiency means lower operational cost. Fourth, it has optimized power management. It enables DVFS, which allows for additional power saving. This is another important factor to reducing overall operation cost while maintaining performance. To evaluate the performance of Apache on ARM architecture, especially on Graviton 4, we use the several well-known benchmarks to test the cost effectiveness. Let's take a look what each of these benchmarks in detail. We choose 5 benchmarks. The first one is SLB and SLB flat. As we know, SLB is based on a star schema, and SLB flat use wide tables models. Both they are used to test analyze capability, which is a common requirement in many business analysis scenarios. Next is the bench. It invoke wide tables. It covers typical queries that are often used in real-time analysis and live dashboards, so it can well reflect the performance of the system in real-time business scenarios. Langless TPC-H. It builds on large of data and include highly compressed queries. These queries are designed to support critical business decisions. So TPC-H is a good indicator of the system's ability to handle complex business critical tasks. The last but not least is TPC-DS. It used a snowflake schema model compared to other benchmarks. It is the most complex benchmark. Make it is closer to real-world data warehouse environment. So it also features more complex queries to test the system comprehensive capability. To ensure the fairness and accuracy of our performance test, we stand up a test environment on ValidateDB Cloud for both x86 and ARM systems. Let's compare two systems side by side. As we can see, the most difference in x86 system and ARM system is the CPU. The x86 systems use X with 16 cores per node and 4 nodes in total. In ARM systems, it used Graviton 4, also with 16 nodes per node, 16 cores per node, and 4 nodes. The memory and the storage is same in two systems. Now let's take a look at the price. It's the most important part. The x86 systems cost $0.8528 USD per hour, while the ARM systems is priced at $0.7982 USD per hour. Right off the bat, we can see the ARM systems have lower hourly cost. Now let's get to the exciting part, the performance test result. The chart shows the total latency of Apache Doris on ARM and x86 across different benchmarks. As we can see, across all these benchmarks, the ARM system with Graviton 4 delivers better performance in terms of lower latency. It's incredible. The performance inputs are impressive. And when we combine with the cost advantage, the storage becomes even more impressive. First, in terms of price, the ARM CAG4X larger is 8% cheaper than x86 C6i4X larger. It means enterprise can save the cost right from the start. Secondly, in terms of query performance, across multiple benchmark tests, the ARM system shows an average performance improvement of 50%. And in the TPC-DS benchmark, the performance improvement is even higher, reaching the 16%. Now let's calculate the comprehensive cost performance. If we consider x86 system is B and ARM system is A, then the performance of A is 1.6 times that of B, since there's a 16% improvement. And the price of A is 0.92 times of B because of the 8% price reduction. So the cost performance of A is 1.6 divided 0.82. This means overall cost performance input of ARM system in the TPC-DS benchmark is up to 80%, 70%. This is kind of cost performance improvement. It's a huge win for enterprise. It allows them to get more analyze power while spending less. So how did we achieve such great performance improvement with Apache Doris on ARM architecture? Let's dive into the optimization details. What we do in the software to adapt to the Graviton 4. The first key optimization is based on the new instruction set. We took two approaches here. One is a translation where SSE to new, which help us port existing code that use SSE instruction to anneal. The other hand is optimize this anneal code for critical path. We have the specific relative to this optimization. This optimization ensures the critical part of the code run effectively on the ARM architecture. We do some hand optimize this the anneal code for the critical path. Secondly, we do some optimization for the third-party library. The goal here is to ensure compatibility between x86 and ARM. Both have the optimization library in the third party. By optimizing third-party libraries, we eliminate potential performance bottlenecks that could come from using unoptimized library, especially for the ARM. Third, we introduced auto vectorization for SVE. SVE is the newest SIMD instruction in ARM. This optimization helps us better use vector computation capability of gravitation 4 and gravitation 3. Vector computation is critical for handling large amount of data in parallel. Fourth, we enhance the benchmark framework for performance validation. We introduced a function-level benchmarking framework. These frameworks allow us to quickly validate fine-grained performance change on the ARM architecture to help us identify performance issues earlier in the development process to ensure that any change we make actually improve the performance, both in ARM and x86 architecture. Okay, let's summarize what we have covered so far and look ahead to the future plan. Firstly, the conclusion: the deep integration of Apache Doris with ARM gravitation 4, AWS gravitation 4 has achieved a perfect combination of high performance and low power consumption. As we have seen, it improves query performance and reduce operational cost at the same time. This is make it the preferred solution for large-scale data analysis. Now, let's talk about the future optimization plans. Apache Doris will continue to expand its support for the ARM architecture. It's a very important work for us. There are two work we will focus on. First, we will conduct optimization based on the ARM v9.0 version architecture. This will involve in-depth exploration of SVE and SVE2 instruction. This instruction offer more advanced vector computation capability. By using them, we can further improve the performance of Apache Doris on ARM. Second, we will add native software support for bfloat data type. This will be adapted to using vector search capability provided by Doris 4.0 version. The bfloat data type is useful in many AI and machine learning relative analysis scenarios. ARM had added native hardware support. It will enable to faster proceeding of the data in this format. Okay, that's all for my presentation today. Thank you for all your attention. If you have any question, please leave a comment down the video. Thank you.